Hello, I'm Francisco. I'm a blockchain journalist working at Zircuit, and I'll be guiding you through how to develop and deploy Dapps on Zircuit. So, first of all, a brief overview of what is Zircuit. Zircuit is a rollup, and a rollup is essentially a blockchain that sits on top of another blockchain that's called Layer 1 or L1 for short. This is also why rollups are commonly referred to as layer 2s or L2s. And the rollup is a blockchain just like Ethereum or many others, which takes user transactions and produces blocks based on the transactions. So the difference here is that the rollup will actually post its data to the underlying L1. So all data that is necessary to reconstruct the state of the rollup, mainly the user transactions, are posted back into the layer 1 data availability layer or DA. And additionally, it also performs state commitments to the L1. So the execution of the transactions and how they are processed in the blocks is done entirely independent of the L1. And so there needs to be a commitment of the state after all these transactions have been processed back to the L1. And this is usually the state root of the latest blocks. And this enables rollup to execute the transactions faster and with more capacity than the underlying L1, since they can produce without needing to wait for the L1 to produce blocks. So you can have a faster block production rate than the underlying L1. This gives us some nice advantages. So first of all, more transactions per second are possible on rollups, and we can inherit a lot of the security advantages that L1 gives us. So since the one is usually a more decentralized and robust blockchain, just like Ethereum, you get the benefit that even if you don't have direct access to the rollup nodes, you can actually derive the state based on the data that is posted on the L1. And you can verify also that the state commitments that are being made are indeed correct in accordance to the data that is being posted. And we also get the benefits of the consensus layer. So to know what is the canonical state of the rollup, you just need to know what is the canonical state of the underlying L1. Since the state is committed there, whatever the L1 decides is the correct blockchain head, we also know what is the correct state of the rollup. And one other advantage of building a system like this is that you can have inter-chain transfers very easily. So usually there are contracts that are specific to the rollup function deployed to the L1, and when the user performs a transaction to this contract, it will be picked up by the rollup, and so user funds can go from the L1 onto the rollup very easily. And just to the other way around, if a user wants to get their funds back on the L1, they just initiate a transaction on the rollup saying they want to get their funds back onto the L1, and when the state root is published on the L1 that includes this transaction, the user can once again remove their funds from the smart contract. And these transactions, when going from the L1 to the rollup, are called deposit transactions, and when going from the rollup to the L1 are called withdrawal transactions. And that's pretty much all you need to know about rollups. And Zircuit is a zero-knowledge rollup, so the main element of this is the sequencer. The sequencer you can think of as an execution client of Ethereum. It takes transactions that are submitted by the users directly on the L2 chain, so on the rollup, and deposits that are made by calling the contract on L1, and produces blocks based on this. These blocks are then posted back to Ethereum data availability layer. Mostly it will be either by blobs or by call data. And these blocks are then available to anyone who wants to derive the state of Zircuit. They will be present on anyone that runs an Ethereum or has access to an Ethereum node. Then, as Zircuit is a zero-knowledge rollup, what this means is that the execution of the blocks is sent to a service called the prover, and the prover will produce a mathematical proof called a zero-knowledge proof that the execution of the blocks was indeed correct. What this means is, without needing to execute the transactions themselves, anyone that has this mathematical proof can be assured that what this contains in these blocks and the state transition are indeed the results of processing L2 and deposit transactions. And the state root that is published back to the L1 is joined by this zero-knowledge proof and is verified on the L1 smart contract, which ensures that the state root that has been posted is indeed correct. And this allows us to have withdrawals in a short window, since once the state root has been published, it has been ensured that it is indeed correct. One feature that is unique to Zircuit is the sequencer level security, or SLS for short. Essentially what this is, it's whenever someone posts a transaction to the sequencer will send it to an AI oracle, which will analyze that transaction and detect if it is malicious or benign. And malicious transactions would be something like exploiting a smart contract and stealing user funds, or trying to make a phishing attempt on some address. And these kinds of exploits are caught by the AI oracle and set to quarantine, so they will not be included in the block, protecting the users from these bad actors. And if a transaction is benign, which is true in the vast majority of cases, it will just continue on and be included in the block just like it normally would. So users and developers get this protection for free. They don't need to do anything to be protected by the SLS, and it does not affect user or developer experience in any way, since this is a service that runs in the background and does not affect normal user transactions. So with all these features, how do you actually develop on Zircuit? Well, Zircuit is EVM compatible, so as you would usually develop your app on Ethereum, it's just the same to develop on Zircuit. So we can use the regular smart contract developer frameworks, such as Foundry, Hardhat, or whatever tool you like to use. And the best way to test on Zircuit is to use our testnet called the Garfield testnet, which is exactly the same as our mainnet, so it's a zero-knowledge rollup. The difference being that it settles to Ethereum Sepolia instead of settling to Ethereum as our mainnet does. So to transact on Garfield deploy contract and interact with them, you need Sepolia ETH, and you need to get it from the Sepolia network to the Garfield through our bridge. So to add the Garfield network to your wallet, you can just use this info, or even simpler, if you go to the Explorer that we have here, you can click on the button Add Zircuit, and it will add it automatically to your wallet. And now to get funds from Sepolia to Zircuit, you can use our bridge, which you can find here in this link. Very simple to use, just connect your wallet, set the amount that you want to set. I'm setting 0.01. It's very cheap to develop on Zircuit, as it is a rollup, so you don't need to send that much ETH. Now we just wait for the transaction to be mined on Sepolia, and then you can check out on the Explorer that the transaction has been mined by the sequencer on Zircuit. It has been scanned by SLS. It was considered to be benign, and you can see that it transferred 0.01 to my address. So perfect. If you don't want to use our UI and prefer to use a CLI, it's also very easy to transfer. So I'm going to show an example using Foundry. You can get it by following this link, and I'll be sending ETH directly to one of our bridge contracts, so we can get all of our contracts on our documentation. And I'll be running this command. So first of all, if you don't have a wallet key store set by Foundry, you can do so by running cast wallet import -- private key, setting your private key and the name that you want to give to your wallet. This will save wallet on your local computer and will encrypt it. So it's one of the most secure ways to save your private key that you use for development, so it doesn't accidentally get exposed. It's encrypted on your computer. And to tell Foundry to use this particular wallet, you export ETH key store account, this environment variable, and set it equal to the name that you gave to your wallet. And once you've done that, you just need to do cast send -- value with the amount of Ether that you want to send to Zircuit. In this case, I'm sending 0.01 Ether. This is the address of the bridge that I took from our documents over here. And the RPC URL is one from Sepolia that you can get from one of the many node providers such as Alchemy, Fura, or many other. So I'm gonna set the RPC for Garfield. I'm gonna set my ETH key store account that I set up earlier, but the name Dev, and I'm going to check the balance of my account on Garfield. So it's currently at 0.06, and now I'm going to perform the bridge by using the command that I showed in the slides. So Foundry will ask me to insert my private key password, and now we wait for the transaction to be mined by Sepolia. And my transaction has been mined, and now I can check my balance, and it has indeed increased by the amount that I've sent. So either by the bridge UI or by directly on the CLI, it's very easy and very fast to bridge Ethereum from Sepolia over to Zircuit. Now, to develop on Zircuit, it's also just using the same tools. So I'm going to show you how to use Foundry. So just create a project using 4Gnet as you normally would with the project name. I'm going to name it Zircuit-example. And then the only thing that you need to do is add to foundry.toml the RPC endpoint of the Garfield testnet. And that's it. That's all you need to do to deploy contracts to Zircuit. So let's do it. So forge it, Zircuit example. Let's go to the directory, open our editor, go to foundry.toml and paste in this address. So by default, Foundry will start with this contract called counter, That is just data storage slots, name number, and the way to increment this number and to set the number. And it also has a script to deploy, so it will just deploy the contract on any given network. So let's see that everything is in order by compiling it. And everything is successful. And so let's move on to deploy. So deploying in Zircuit is just as any other network. The difference is that we have our custom built block explorer that I showed earlier. So this is different from ETHGlobal, and therefore the way to verify contracts is also slightly different. First of all, there is no need for any API keys. Instead we use a service called Zircuit to verify the smart contracts. And so when you pass the verify flag in the Foundry, you also need to pass --verifier Zircuit to get your smart contract verified on chain. So let's run this command. It's going to be spelled here. So it will ask for my key store password once again. It has deployed my contract. It has detected that it's verifying on Zircuit, so it's trying to verify it now. We can go ahead and copy the address of the contract we just deployed. And we can go to the Block Explorer and search for it. And here you have the contract that we just deployed, and it's already verified. So yeah, it matches to what we had before, and we can check the API, can interact with it directly on the Explorer. So let's check out the stored variable. Yeah, it's 0 as it has never been initialized, and we can even interact with the contracts. So if you press here right, it will invoke the function increment. And now, yeah, and it has mined the transaction, and you can see it. It has decoded the input data. Its transaction fee is very low. As you can see, you can get started on Zircuit with very little ETH. And if we go back to read contract and query it again, yeah, it's now 1. And we can do the same for the set number. So let's say 10. But transaction has been submitted. And if we read the contract once again, it is now 10. So yeah, the Explorer has this nice interface. If you just want some quick prototyping and testing, it's very easy to interact with the contracts. But if you want to develop, let's say, a web app, you need to use other tools, just like VM ethers, and these also work out of the box for Zircuit, no changes needed. So let's try now to interact with our contract using V. To do this, I'll go back to our codes and I'll use bun to create a script. You can use whatever package manager you prefer. And I'll install VM. Okay. Now let's see if we can connect to the Garfield testnet. So Garfield testnet is on VM baked in, so you don't need an RPC endpoint or anything like that. I could just do one run index.ts. Oops, and I'm not showing anything. So let's log the block number. And it is 536, which, yeah, that's right. Zircuit has blocked every 2 seconds, so this number increases quite fast. Now, if we want to interact with the contract that we just deployed, just gonna grab the artifact that was produced by Foundry. And then I'm going to create a contract instance. So the contract was deployed to, let's see, to this address. I'll just paste. Oops, let's see. Okay. So I'll just paste this in. And by running now and checking what the number is, it should be 10 again. So just the same as we saw in the Block Explorer. And that's it. That's all you need to know to develop on Zircuit. It's that easy. So here are some useful links. So the links to our documentation, it contains more details on the Zircuit network, the architecture, the contracts, the address for all of our system contracts, and some other useful information. The Explorer that I used during this tutorial and the bridge that I used during this tutorial. So very simple and nice to use. And I hope you enjoyed this. If you want more updates on what we're working on, you can follow us on Twitter. And if you have any questions, don't hesitate to reach us on Discord. We'll try to get to your questions as soon as we can. And I hope you have fun building on Zircuit.